Welcome everyone to another episode of Cloud Coaching Session. My name is Gawale. I'm a senior cloud virtualization specialist at Oracle EMEA. Today we'll be learning about on how to scale the OpenShift cluster in OCI using assisted installation method. I'll just give you a minute to go over the safe harbor statement before we jump into the rest of the presentation. Let's look at the high-level steps on how you can scale the OpenShift cluster in OCI. We will start from the Red Hat console and we'll add the host in Red Hat console. We'll generate the discovery ISO and we'll upload that to the object storage so that you can create custom image, which should then help us to create necessary nodes, whether it can be worker nodes or control plane nodes. Once the node installation is done, the OpenShift cluster installation will be completed by following some additional steps, which we will see as part of the demo today. Once the installation is done and the nodes are ready, they will be accepted to join into the OCP cluster. Let's look into the lab, how these steps will be performed. I logged into my Red Hat console. I'll just show you first the cluster which was provisioned for OCP. Go into the cluster list. OCP demo is the cluster which I recently provisioned, which basically has 3 compute nodes and 3 control plane nodes as the default installation. However, I also added additional host as the worker node, which you can see here as well. In this demo, we will add additional worker node. You can perform the similar steps to even add control plane nodes as well. In OCI, the resources will look like this, wherein you have the worker nodes or the compute instances, control plane VMs. Then you'll also have the load balancers created as part of the assisted automated installation using ORM stack. You will have API INT and API apps. 2 load balancers will be created. API apps will have 3 different backend sets. One for API backend, other 2 are for HTTP and HTTPS connection. In the API backend, only the control plane VMs will be added. In ingress HTTP and HTTPS, control and worker plane nodes will be added as well. Now let's go back to the Red Hat console and try and perform the steps to add the host. We'll leave the default CPU architecture. We'll use the SSH keys and generate discovery ISO. We'll then download the discovery ISO so that we can ensure that we can upload this to object storage. So let me navigate to the storage and the bucket ISO. I created a bucket named ISO. Let me delete the previously uploaded ISOs and upload the discovery ISO which I recently generated. Click on upload. It's going to be a quick work. Close. Now we completed our first step wherein we added host, we generated discovery ISO and uploaded it to the object storage. Now the next step is to create the worker nodes. But before we create worker nodes, we will have to create a custom image out of this ISO. So let's go to compute, custom images. And let's click on import image, give it a name. We'll leave the operating system to RHEL and then we'll select the ISO which was uploaded in the previous step. We'll select the image type as QCOW2 and leave the rest of the setting as default and click import image. The import takes a couple of minutes, so I will pause the video and come back once the import is successful. All right. The Let me share my screen. Okay. The import has been successfully completed. So we created a custom image for us to provision a worker or control plane node to scale out the OpenShift cluster. So we'll use this ISO or custom image rather and create instance out of it. To refer to the existing setup, I can just check the resources allocated for the existing compute nodes, which in this case is the specific shape, CPU and memory count, as well as the storage associated with this specific compute instance. However, you can choose any shape that you want in terms of scaling out your resources or scaling out your OCP cluster, but I will keep the same settings here. So let me go back and use the same nomenclatures here. So I use the same nomenclature and I want to provision a worker node here. Choose different availability domain. This is the custom image that we created. I'll just change the shape to E4 Flex, 4 OCPUs and 16 gigs of memory. Now, in terms of networking, this is my private cloud, private OCP implementation. So I will select the private network and click on Show Advanced option to attach the network security group created for the compute or the worker nodes. No need to supply the SSH keys because at the time of generating the ISO image, we embedded the SSH keys. So the SSH keys are already presented and available in the ISO itself. You can specify the custom boot volume size and change the virtual performance unit according to your performance requirement of your worker node or OCP cluster. Click on Show Advanced options where you can attach the necessary tags. So my cluster name is OCP demo. So at the time of assisted installation, a Terraform script will create necessary tag namespaces and tag keys. So when we create the instances, we just need to select the instance role. And if it's a control plane, assign it to control plane as a tag value. But now we are provisioning a worker node, basically a compute node. So I'm assigning the tag value as compute. Go ahead and create it. Our instance is up and running. The next step that we need to take is attach this instance to the instance pool. When you attach this instance to the instance pool, it will automatically get attached to the load balancer as well. So let me show you the instance pools configuration here. And just because we have added this as a compute node, you can check the compute instance pool. You have to go into the attach instances and you will find the existing compute nodes. And you will also see that the load balancers are attached to this specific instance pool configuration for the purpose of scaling it out when the node gets filled. Now, let me go ahead and attach the newly created instance here in this specific instance pool. So let me select the OCP demo compute 5 and let me attach it. Meanwhile, let me go ahead and check the load balancer status. So I opened the load balancer for API apps. And as you can see, we have API backends, which are control plane nodes. That's why the value of number of backends is still 3 because we have 3 control plane VMs. However, for the worker nodes, you would notice that the number of backends are getting updated here. As you can see, it had changed from 7 to 8 because the newly added worker node has been updated into the backend set as well for ingress HTTP, and it will also be updated for ingress HTTPS. So the newly added worker node belongs to the load balancer now. Now, before we move on to the next step, I would like to show you a few details on the load balancers, both of these load balancers. In the API apps load balancer, we only have port 80443 and 6443 for API backend. And for API INT, API internal load balancer, we have the backend sets that all belongs to the control plane VMs only, has got the MCS and MCS2 backend sets configured for the ports 22624 and 22623. So for MCS2, we have 22624. The reason that I'm showing you it here is because at the time of scaling out this cluster, you will probably notice here that the newly added node pops out here. So let's just see and wait here for a sec. As you can see, the worker node started to populate here in the OpenShift console, but then you get error message saying insufficient. If you look at the error message, all right, okay. So we changed the role, so we can change the role here. But typically, what happens when you try and install the ready host? Let's just see if so the host becomes ready, and you click on install ready host. So let's see the installation gets successful, and then just wait for it to get installed so that we can join this node to the cluster as well. Okay, the installation has been successful here. However, just because I'm adding this node, second node in this specific operation, I previously added compute 4. In case if you get an error message here saying that it cannot download the ignition files because it is trying to communicate on port 22624 on the apps load balancer, this is the common error that we usually get when you scale the OpenShift cluster. Basically, what happens is that when you try and when this OpenShift cluster scaling operation try to reach apps load balancer on port 22624, which is MCS2 port. However, if you notice here, there are no backends configured for MCS2. To work around this, what you can do is when you get that error message of the ignition file download issue and it tries to communicate to the API apps load balancer, you can just change the host name from API apps load balancer to API INT load balancer, because in that case, you are able to receive the communication from the OCP cluster or the load balancer on API INT on the MCS 22624 port. So let me just show you on API INT load balancer here. So what you just need to do when the scaling operation is happening, and if it throws you error that it tries to communicate on OCI, the API apps load balancer on port 22624, you just modify that FQDN and change this to the API INT load balancer FQDN, and then you should see a successful installation of your node. To find out the DNS zone names of these load balancers, you can go to the networking, go to the virtual cloud network, open the VCN where you have installed OCP cluster, click on DNS resolver, and go to private views. In the private views, you would find different zone names are created. Go to your OCP cluster zone name, and here, this is the load balancer for API apps. And this is where it tries to communicate on port 2264. You just have to change this to API INT and the installation will be successful. Now in this case, it went straight and it got installed successfully. Now the only thing that we need to do is we have to approve this cluster into this node into the OCP cluster. To do that, log into the OpenShift console where you can manage the different nodes and the containers. Go to compute and select nodes. There you will find the newly added worker node available in a discovered state and requires and waiting for your approval. So click on discovered and click on approve. Once you do that, the status will change to not ready. Again, click on not ready and click on approve for certificate signing request. So once the certificate signing request is completed, your node will be joined to the existing OCP cluster. And you will also see the information will soon start appearing here related to the node in terms of CPU, memory, the file system details, which is basically storage details. And once the status turns to ready, even the pods will be scheduled to run on the specific worker node. Now, as you can see, the worker node is in ready state. Thank you so much for watching. This ends the demo on how you can scale the OCP cluster in OCI using assisted installation method.